So the schedule today is, first we're going to talk about sort of FVM capabilities and direction. That is like, what's special about the FVM? What could be special about the FVM? What do people want to build or want to get out of blockchains? What do people not really, or sorry, like, what are some missing parts of the FVM? What are people's frustrations? This kind of stuff. Actually, Amache, could I ask you to take notes? Thank you. I just want to make sure we recorded this, because a lot of this discussion will be like questions for you. I'm actually going to be saying very little, hopefully. I tend to talk a lot. But yeah, so the first section is all about sort of looking wide. The next section will be about looking more deep into specifically WebAssembly and like the potential paths to enabling users to deploy WebAssembly modules on the network. And all of the gnarly details there and why it's difficult, and then also a little bit more about, okay, why? Like, why are we doing this? Because like all these different options will have trade-offs, where some of them will be more secure or easier, some of them will be like much more performant, so it's the trade-offs. And the final section will be on addressing, which is actually taking a complete turn, but if you're interested in like how addressing works in the Filecoin network, and some of the problems we're running into from a usability perspective, given we have 5 address classes plus 0x, please come. Okay. In this first one, all of the text in orange means it's a question for you. It's something I want you to answer. If it's in green, that means it's something that already exists. Otherwise, if it's like gray, that means it's something that like we could do, but we don't necessarily do today. So the first part is I really want to open up and ask people like what and why, why do you or what frustrates you about the FVM right now? Why? What frustrates you about blockchains and VMs and blockchain VMs in general? Why? What excites you about the FVM? Like, why do you actually like it? And what's missing? So I guess we can start at any of these questions. If people want to spend some time brainstorming and thinking, or they can just start asking questions.
I'm happy to start. Frustration. I've heard frustrations from a chunk of people that they don't have access to enough like APIs and ability to connect to internal systems inside the Filecoin network to do useful things related to like data DAOs, where they really want to be getting more access, and the current APIs are like limited in the ability to do that. Obviously, I've also heard a lot of frustrations around the complexity of trying to work with existing smart contract DX tools that don't fit well with Filecoin's F4 address class, and the complexity as a developer that creates. Just going to skip to excited. I think there's a lot of opportunity for us to push a lot of the current actors in Filecoin into the FVM and enable like iterability, forkability, improvement that is smart contract based instead of network upgrade, hard fork based. And that would just save all of us developers like so much time dealing with difficult network upgrades if we can move much more of that into user space as much as possible. And so excited to just use FVM, the runtime, as the runtime for all the things, and try and avoid as much as possible lots of built-in components outside of FVM.
I guess maybe the first one is kind of equivalent to Molly's input, which is kind of feels like using a completely separate network that happens to have consensus based on proof of space, because like I'm not able to interact with like most of the things that I would love to interact on the FVM. Generally, what is exciting potentially on the FVM side is of course having like multiple runtimes, but also thinking about potentially like having the structured storage, like chain state, as a new tier of storage that is
as
like
a what?
New tier of storage that is structured storage, and possibly even thinking about like a different block reward structure for that. Because
I'm confused. How does that? So like, what do you mean chain state is structured storage?
So now that we have like layer 2s, so now we'll have like more.
Could you hold the mic a bit?
Yeah, sorry. Is it okay now?
Yes, it's just I'm having a bit of trouble.
Yes.
That's fine.
So now that we have interplanetary consensus, we'll have like more space for the state
On chain.
on chain, yeah,
Yeah,
and
inside
you
chains,
could
yeah.
think of that chain as a new tier of storage that is super scarce, of course. But since you have like more L2s, potentially L3s and so on, we could think of that as potentially like a structured
Yes.
state and probably the only structured natively state for Filecoin and the subnetworks. And that's super exciting to think about that, and possibly like the way that would interact with like WASM executables and so on. Like you can do some pretty cool things. And yeah, like of course, like WASM is missing and interactions with native abstractions like deals and so on.
Yeah, so one possibility there that we have discussed is this idea where, at least on side chains, you could even access sector state potentially. Effectively, what you could do is say, okay, we have the side chain that is composed of a set of miners or storage providers that are like they all agree to store the same sectors, and they agree to make that all that state available to the chain. At that point, there's a question of like, do they really need to be well? I guess, yeah, they would want to prove this because then they also get like, they get incentivized to store this data with L+ and the block reward and all this kind of stuff, where basically they'd be proving this data, the fact they're storing the data to the main chain, but then making it available on a side chain. But yeah, that is an interesting direction. Thank you. I'm also really curious about like, oh, sorry, you have anything else?
Yep.
I'm also really curious about like any specific like questions about like, I guess, things people want from the FVM itself. So like we're talking a lot about like ecosystem and things you can build on top of it, but I'm actually really curious about like, is there a missing feature in the FVM or the VM or any missing feature that you've seen in the EVM that you want in the FVM or anything in like the EVM that you don't have that you really want? It's something that doesn't exist in blockchains in general that really frustrates you.
What frustrates me about the FVM is that I can't write native actors.
Can't run what?
Native actors.
Got it. Thank you.
And when you say native actors, you mean actors in WASM?
Yeah.
What?
We don't use native for like WASM actors.
WASM actors that are high performance, the same as the built-in actors.
Yeah. So, but the question is like, why? Why? What about this frustrates you? Like, what are the parts that frustrate you?
Number one, because of my background, that's the thing that I'm good at, and so there's a set of people who are good at that thing.
But I guess the question is like, is it performance? Is it language? Is it just like
No,
the
it's
way?
natively speaking IPLD, for example, which is the native state storage of the network.
Okay.
Natively being able to communicate to other actors, including the built-in ones, when they have the appropriate APIs. I understand the missing API problem as well. But being able to do things the direct way rather than through a layer of abstraction and indirection that is not helpful, except to people who know how to code Solidity.
I'm just wondering, because there are some intermediate solutions as well. For example, like if you want to be able to work with IPLD better, we can expose that better to the EVM. If you want better performance, that's not going to happen in the EVM, but also in many of the options we have in WASM, it might not happen there either. You might not get the better performance. If you want something like Rust, yes, WASM gives you something. It gives you Rust. It gives you whatever language you want that targets WASM. That's why I'm digging into this and like trying to understand what part of WASM is important, what part of WASM is less important, because that will also inform the potential like solutions there and other things we build.
Yeah, it's not the Rust part that is important, but it's the speaking the native protocols, the native data models of the environment that I'm operating in.
Okay.
From my perspective, the Rust part is a bit important. Not as much as speaking the native models, but more about duplication. Duplication of decoding, encoding, duplication of modeling we do, libraries we develop, and so on, right? So there are multiple processes that require some more complex computation, and today we have to implement them either in Rust or Go for implementations, and then we have to implement them in Solidity for the verification, let's say on-chain verification, which was, for example, how PODSI is done, right? There's a Go implementation, because I couldn't get, Rust implementation wouldn't buy me anything, because Solidity implementation would also have to happen.
Yeah, that makes sense. I also have a bunch of other slides and prompts, so if people have any.
Thank you. Yeah, one thing from a more strictly programmatical point of view is we are missing backwards compatibility in FVM. As Forest, we need to support several versions of FVM, and because of Rust restrictions, we need to support several types of the basically same object, even though it only is different by its version number, and that's like giving us quite a bit of work on every network upgrade. So that's like pain point I would like to mention.
Yeah, that is, I just did that work for Lotus, and it, at least in Lotus, it's not like, we have a nice shim, so it's only a couple of files we have to basically copy and like tweak, but every single time it's a bit of a pain. Yeah, like actually I'd like to talk to you more about that later, because like there are a bunch of options there. One is I think we do need some kind of shared types crate, shared between all the different versions. The other part is actually moving these all maybe into a single crate with like separate submodules in the net crate. Yeah, supporting multiple versions within like the exact same source tree with like a bunch of if-defs is not something we really want to get into, because like every single version, like we change some deep components, and like having lots of version checks. We do this in Lotus, but it becomes hard to maintain over time, and it's much simpler to just sort of say, okay, no, we're just going to copy paste the tree and then start anew. But yeah, I feel that, and I'm really sorry for not getting this fixed earlier.
Thanks.
Hello, and a couple, I mean, these have been mentioned before, and these are not strictly FVM things, but just for completeness, I want to reiterate them because there's certainly something that are encountered when developers develop with FVM. So the first one, I suppose, is the addressing you've mentioned about the fact that we've got all the different address classes, and that's a pain. I mean, Filecoin, FVM has been launched for 6 months. We've just finally got Coinbase to start allowing withdrawals on F4 addresses, or withdrawals to F4 addresses. Binance still not doing it, right? This is 6 months and we still can't get it, and this is just, that's a relatively minor change for them.
I do want to be very clear here, though. That has nothing to do with the FVM.
No.
That has everything to do with the original choices we made on address classes.
Right, exactly. That's what I'm saying. Some of these things are not to do with FVM, but are certainly very much exposed by the usage of FVM by developers, right? So I'm just mentioning these for completeness, although they're not.
Kind of. But it's like any addition of an address class would have caused that exact same problem.
Yeah.
Yeah.
Then the other one is things around block time and finality. Again, not FVM directly, but developers then start to develop on FVM, and they suddenly go, well, wait a minute, why would I use FVM when I could use, say, this other like layer 2 and get faster, cheaper transactions, unless, you know, the thing I'm doing specifically requires access to Filecoin stuff. And then the third one is, you know, everybody comes up and goes, oh, great, FVM, great, so I can access my storage now. No, you can't.
Yeah.
And so, you know, the storage state idea, yes, that can get there. I know there's been some discussions around that, but that's one thing that continually we bump up against.
And also, there are two ways of going about that, really. And one way is the one Whirl has been proposing. I don't know if everyone here has seen it, but it's this idea of like saying, okay, like you could basically put a bounty on chain for storage, then your storage provider would go and like put some subsection of your sector or piece on chain so you can compute over it. The other way of doing this is the sidechain approach, where you have like use IPC and say like separate side chains or like subchains could basically agree to give access to their sectors to the subchain. So two different approaches.
I'm not familiar with either of those two ideas, but two others that I think are, two alternatives. One is an existing proposal to store ComD on-chain, which then gives on-chain access. This is expensive. We shouldn't do it for all the time, but we can make it possible. And then in some cases, it'll be worthwhile. Another one is any Oracle network could provide access to sectors anywhere, including onto the Filecoin main chain. To some extent, with the protocol designer hat on, I wait for evidence that something is wanted desperately before considering it as something worth putting into the core protocol. The existence of Oracle networks would be a flag that we could optimize the Oracle networks away by putting it on chain. The fact that I haven't seen an Oracle network leads me to think it's not an urgent problem.
Yeah, although I think one part of this is like, I think one thing would help would be having some kind of guarantee that you could actually get your data on chain. And while provable retrieval off-chain is not possible, provable retrieval on-chain is actually possible. So we can have a system where like when you make a deal on-chain with some piece of data, you can require that the storage provider that accepts that deal give you your data. Like this is possible to enforce on chain. Or sorry, give you, or how to put this? You can require that like when you send a special message to a special actor on chain, the storage provider must sort of complete the other side of that and put your data on chain to complete the operation. And so you can make that into, you can add that to the deal flow and the market flow, in theory.
I don't know, Alex, if this is the Oracle system you're describing, but it's the data bounty one that I think Stephen was mentioning, which is, you put up collateral for anyone that brings that data on chain for you, but it's not a specific Oracle, it's anyone can post that data on chain, and that is actively being done by multiple different groups right now. I've heard of it from at least 2 or 3 groups in the FVM space where, and it's great, it's awesome that they're solving problems, and if that does fully solve the problem, fantastic, but they're effectively posting bounties for anyone that are redeemable by anyone who then puts like the data for XYZ CID into chain state for then that actor to keep executing.
Yeah, that's good. There's a like subtle distinction here between the data for XYD CID and XYD CID itself. At the moment, even that is not on chain deterministically, like it's inside the market deal, but it's not necessarily on chain for, well, it's not in the sector data. So there's 2 things is an Oracle network could provide the CID, the data CID, the data commitment behind a sector, and then yes, anyone could provide the data and a proof of inclusion into that.
But no, the data CID doesn't actually have to be inside the sector for this to work, because you can have a separate actor where, like, basically as part of accepting the deal, you are agreeing that like the deal contains some set of data, and that you're willing to make that data available. So like that doesn't actually have to go into the sector into us, at least in theory.
Yeah, we just got to make sure that data commitment is on chain somewhere,
Yeah,
so a smart contract can prove that the data that comes in later
exactly.
actually was in the sector.
Yeah.
I just want to make a quick comment on what Alex said earlier. It's like the reason why we are not seeing oracles to be built is not because like we don't see an urgent need for them to be built. It's just like Filecoin is so complicated. People don't know how to build tooling on top of Filecoin. Matt has been on multiple hackathons. We have like hackathon rewards for like different toolings. Damn hard. All the integrations we have to be done with the ecosystem, like Lighthouse, building the deal bounty, like the flow, took months, at least 6 months. And now we are still just working on something alpha. So it's like, I personally feel like also Soundex is here building like barracks, like the transaction indexing, EVM, like for archival node, the graph node. Everything is very complicated. So in my humble opinion, like it will be great if we can actually talk to the builders and understanding why it's so hard to build on Filecoin rather than assuming there's simply no needs, and that's the reason why we don't see things existing in our ecosystem, because like people want to build those. It's just taking time.
I'll just chip in there and say a lot of that is in some ways to do with, for a lot of use cases, there's easier ways to do it, right? In many cases, when we're dealing with hackathons, they're like, oh, yeah, we're using Filecoin. Oh, yeah? Cool. How are you using it? Oh, yeah, we're just uploading to IPFS and getting it back down again. And that's like, from their point of view, that's them using Filecoin. They're not using Filecoin at all. They're just using IPFS. But that does the job for what they need, and they think they're using Filecoin, right? Now, if that does their job, that's fine, but it's not, it's not Filecoin.
I feel the answer there is actually just come to the users then. If they want to use IPFS, great.
Yeah.
Make a flow that integrates with IPFS that then like gives them the proof so that they can check it easily, and they don't have to change anything. We just make sure it ends up in Filecoin.
Right.
Just to quickly dovetail on that. So I haven't used a ton of FVM stuff recently. Fission did a lot of things with the built-in actors pre-FVM, and we thought it was great, basically, right? It was just like, things were really simple, you could compose them together. It was awesome. Are the things that we're talking about here irreducible complexity, or is it about how they were implemented, design decisions, and then we have to handle them with tooling, or like is this something fundamental to how the system is built, or is it an issue of the interface?
There are a couple of parts. Part of it is that like the markets and all that system was not designed for using it with smart contracts, and now we have to go through it and make that happen. Really, a lot of it just comes down to the fact that the system was not designed for using smart contracts. So those endpoints are not exposed. The other part is like there are a lot of complexities. So for example, like our addressing system is complex because we want to support all these different systems. Like the integration of the EVM into into the FVM is also complicated because like a lot of chains that do this, they just take the entire EVM, put it into a single program, and then run it as a separate world, and then it like has to like go through basically a proxy to communicate with the outside world and treats the outside world like another chain. We didn't do that. We said, no, we want this to be first class and integrated, but that also just makes it more complex. So that just means people like, basically because they're trying to do more, because they're calling back and forth so much, they have to like deal with these different APIs and stuff like that. Part of this is also just lack of tooling. Like our libraries and APIs for like interaction with the native actors from Solidity are not great. And a part of this is just the fact that Solidity is not great. We like to make this work better. We probably need to like write some proper like code gen tooling to make this work. And we'll have a session on that later, actually about like code, like basically describing actor interfaces and actor state trees and stuff like that, and then potentially like writing code gen tools to like actually generate like the code for this. But the first version was much more hacky than that.
So in a lot of projects, like take Go, for example, right? A big part of its success was that it had a kitchen sink standard library, right? And it's like, you want an HTTP server? It's baked in, right? And I get that we're trying to get to having anyone be able to deploy code so that it's not all on the core team. But for the things that are really high value, would it be worth just having an opinionated, like, here's how you talk to IPFS, here's how you talk to this thing, here's how you talk to that thing?
I would agree, I would support that. And that's one of the things I think we see, and I think it's exactly trying to draw the line as to how much do we want to support and we want to be opinionated on versus others. But there's certain things that, like you said, there's oracles. You said there's several people, Molly, building oracles to do this kind of storage sort of thing. Well, yeah, we could, if we just had one defined one that did it quite easily, similar with some of the stuff we're talking about replication and renewal. If there was one, fairly opinionated, simple object, you can go build your own if you want, but it just means that out of the box, here's some functionality that might do 90% of what you want. If you want to go and do something slightly different, you can go and build your own.
Yes.
Maybe last one. So like a couple things. So on the Oracle side, like there is a bunch of people that are just figuring out how to do things. Like you don't have exposure to anything that is related to the sector state. So whatever you want to do with the sector state, like you need to figure out to get to that piece of information. Now, on the other hand, like I think like actually like the FVM, EVM, like prioritization of the EVM actually brings a lot of value to Filecoin, but like kind of let's also be aware that those are kind of like the bad developers that of course like we need, and like people were copy pasting like contracts from other chains and trying out things, and of course like that's great, but there is a big opportunity for us to actually like do the other part like really well, because like we have a very different setup from like most of the other chains. So it's not like competing with Polkadot, with the Wasm contracts. It's basically allowing you to interact with storage, and like really figuring that out well, and like also figuring out the tooling for that like can be like super powerful. Right now, we are kind of like IVM that doesn't do like everything that like other networks do easily. So you need to put more effort to do it, and then you're assuming that you get some other nice things, and usually you don't, like most of the ones that you have assumed. So.
Okay. We're running low on time, but I do actually have a couple more things I want to talk about. I might steal a bit of time from my next presentation. But yeah, so I actually have 2 or 3 more topics. So the next interesting thing about the FVM is it is WebAssembly based. And some of the cool things we get here that we're already using, they're all the ones in, oh, I guess they look yellow up there. They were green on my screen. Fine. The things we get are like high performance, some nice static analysis, and the adoption momentum. Things we're not actually doing right now that I think we really should start taking advantage of are, for example, code upgrades or easy code upgrades. Or something I've been worried about for a long time is, okay, like what happens if we want to change an FVM interface? After thinking about this for a while, I realized it's not an issue, because like Wasm is super structured. So you can literally take an actor that's on chain, take another Wasm module that translates from like one syscall interface to another syscall interface, and then you can link them together and produce another Wasm module that just calls the new syscall interface. So this provides a really nice way to perform chain upgrades, and literally not just migrate state, but migrate code on chain. Even if it's not your code, you can migrate user code this way. So I don't know if we should do this, but this would definitely make our lives a lot easier. The other cool things about WebAssembly is like you get web support. Like I really, really wish we had a nice like web browser friendly implementation, like a light client. But if someone wants to build that, that'd be great. Another thing is we get common targets for multiple languages. We only currently use Rust. It'd be really interesting to see what other languages people might want to use here. I'd also be really interested in hearing more about like. A lot of this can be Brooke, because she knows more about WASM than I do, about web support. Because I know like on the web right now, with the way WebAssembly works, async is not well supported. Is this going to change at any point? Are they going to see the light?
I mean, so you can ship your own async
Yeah, but then you have to-
runtime into it. Like it's single-threaded concurrent async, right?
Yeah.
Not true parallelism. People have done things like, push them into web workers. And now you have true parallelism, right? But that's like at a layer outside of the WASM itself. So do you mean the threading API?
No, so sorry, it's a bit of a digression for people, but like what I need here is the ability to basically run the FVM in the browser while accessing state that may not be local. So the state requests might have to go to the network and come back, which is going to be an async request.
We do that already, yeah. So we have, might be too in the weeds, but we use so not using Filecoin, right? This is all IPFS and other things, right? But all with WASM. We use a layered block store, similar to what you guys have. And that all executes asynchronously. And it's totally happy because we have everything off in a thread, off to the side, like in a web worker.
I see, and it can just, so the web worker can actually pause while
Right.
it's waiting. Oh,
Yeah.
excellent, okay, thank you. Yeah. The other question here is like, do people actually want to use multiple languages for deploying actors? Or is there any interest in like scripting languages or something like that? Like I'm just wondering if this is a need people have, because I know that people do use this in like, somewhat in Ethereum, it's much more common in like, Bitcoin and in like, in Solana, it's like literally how you do everything.
Yeah, I expect supporting assembly script or similar would lower the bar to getting started for many people.
Well, there are two versions though. So like there's assembly script for like actually writing proper WASM actors, and then there's like literally like my message is a script. It's like super compact and high level and gets executed by something. Like, do people have experience with this? And like, is the feature that's desired from the FVM or?
Like you mean to do it at runtime as opposed to not compiling it ahead
Yeah,
of time?
as like my point is like you just need to like basically send a run once script to the network. Is this common? Yeah.
If you're describing systems similar to Bitcoin's
Yeah.
script system, it's like I'm not aware of any other network than Bitcoin.
Well, I know Solana
Setting
does
up.
this as well. I think somewhat.
Okay, yeah, maybe.
Over time, I have thought of a couple of use cases for this, but none of them have seemed good enough to justify the sort of conceptual complexity that could be introduced by that.
Yeah, the only reason I'm bringing this up is like, this is potentially a reason to have more like runtimes and stuff like that. Because then you add like a Python runtime or something like that, where you can just like, not necessarily Python, but like, yeah. Oh.
So if there isn't like a, and I know that, this is trying to get the feedback from the community, right? But if there isn't like a really, hair on fire use case for it, it may be worth pushing it off as long as possible. And because you can still do this, you could deploy an actor that takes as an argument source and runs it. And if a bunch of people start doing this, then that might be a sign that it's worth going deeper.
Yeah.
But if nobody's doing it today, then like maybe that's also a signal.
The reason I'm asking is this is a reason to potentially consider pushing for native WASM actors. Like if people need this ability, native WASM actors would let people deploy those interpreters and stuff like that. But yeah, okay. So I'm going to move on to the next one, which is IPLD. This is another unique capability, or actually, sorry, the previous one's not unique. This one is a unique capability of Filecoin. And it the fact that we use IPLD does cause some problems. But on the other hand, it does have some really, really nice advantages. The first one really is the fact that everything is copy and write. So we actually use this in a couple of cases. For example, like we can send large sharded data structures between actors for free. We don't currently send sharded data structures. I'm actually interested if people are interested in doing something like that. Currently, we do send large structures, though. For example, or large objects. For example, when you deploy, or once you've deployed EVM bytecode, the way we do delegate call, sorry, forget the EVM bytecode. The way we do delegate call in the EVM is we have one system call that retrieves the bytecode CID from the actor you want to delegate call to. Then it returns that bytecode CID. Then you send the bytecode CID to yourself and say, please run this bytecode as me. And then you load that bytecode and run it. But it means like you're not paying all the cost for like copying all of this data back and forth. Like you're still having to copy and load the data, but it's less like loading and serializing and all this kind of stuff. For example, like when you call the other actor, that other actor is not loading in their entire bytecode. They're just like loading a reference to it and sending you the reference, and then you get to read it in yourself. So like, I'm wondering if like people have other use cases for this. They might like think this is something they care about. The other interesting thing here is we can have content address code objects. Like right now we already use content address code for like actor code, but something that's interesting is, for example, how to put this? Like right now, like if the standard way to expose large data sets is to expose an API and let users sort of like query this API to like walk through this large data set. The tricky part about this is like, this might not be atomic. It requires you to have some kind of cursor interface. And Alex, this is actually something you might be interested in. So like this is relating to like the NFTs work you've done and the tokens and stuff like that. And like I remember you were working on like how do you like have a cursor over a HAMP and stuff like that. One option here is to have the ability to, I think we discussed this before as well, the ability to basically like return both like a reference to some data and a reference to some code, and then instantiate that as a program, and then just call into that repeatedly, and basically you have now this constant process. I'm wondering if this is something people have felt missing, or felt that is missing in blockchain systems, or if there's a reason that you just don't want to do this.
I would be worried about security of sending over code, because it seems like you would want some isolation.
Yes.
But at that point, the isolation is just calling out to another actor, right?
Well, so you would get the isolation. The idea is basically you would receive the code CID and the data, but then you would instantiate a separate WASM process that would have that code CID. And then basically keep on calling back into the point, though, like basically the difference is right now actors are not long-lived. We're like, I call into an actor, it spins it up, it does its thing, it returns, it shuts down. In this case, you basically say, spawn this process, and then you keep calling into it, and the process sticks around. That's the difference.
Wouldn't you be able to? Okay, but it's all within one execution.
Yes.
Okay.
Yeah, and the other question here is maybe we should do this with actors themselves. Maybe we want actors to be longer lived, if that's a thing.
Yeah, it just seems really complex to me. I can't justify the complexity for what you get out of it, given there are other ways to achieve similar outcomes.
Yeah.
The ability to transfer data and like some code module thing, the ability to load code that is deployed would give you basically everything.
Yeah, fair enough. Like the motivations, I guess there are a couple of motivations. Like one is this idea of like not having to care about the structure of the data. Instead, all you have to do is agree on the API, and then people can sort of like keep on iterating on like the underlying structure of these HAMPs and whatever. So like right now, like we try not to we don't just send like the CIDs of HAMPs around because we want to be able to change the underlying data structure in the future. If we had some intermediary code module, this would help there. The other reason to do this, like this gets into the next topic, which is processes and IPC related things. Eventually, we'd like to ideally move a lot of the block execution logic out of the FVM and into actual like actor land or into WASM, because this makes it easier to run this on different systems, different platforms, and browsers and stuff like that. It also makes it easier to evolve the protocol because now like we're just upgrading actors effectively instead of having to like upgrade the FVM. But those are some of the interesting reasons. But Brooklyn has it.
Just for my own understanding, is this for the host or for the guest? Like, are you talking about doing this loading dance as an exposed thing in the
to the actors?
To the actors that somebody could program with?
Yeah. So
not an optimization lower in the stack.
No, not an optimization. The idea is literally it would be a concept where like as an actor, you could say, hey, here's the CID of some WASM module. Please start this process. And it won't be able to run in the background. It'll sort of start up, then return to you, and then you could call into it, but it'd be more of a long-running WASM process, kind of like the way you get in browsers, not like a short-lived, you call into it, it starts, it runs, it returns, it shuts down. That's the difference.
For efficiency reasons, or because like blockchains are usually have a fork join model, right? Where they like fork the entire world, try their thing out.
Yes, this would not be a fork join model. Yeah, so
Okay.
so it's for efficiency reasons, it's for convenience, so now you don't have to have this cursor object that you have to like keep on passing back and forth or anything like that. The main thing really is efficiency though, because it means like you can keep some intermediate state and keep on sort of querying without having to like restart the query every single time. That's really the only reason to do this.
So to summarize, it's essentially allowing you to send over data and coroutine that's capable of processing that data and outputting something and then like you can get something out of that coroutine. That's an interesting idea. I don't know.
Yeah. It may also help with like reducing code sizes, where like instead of having to like build everything into one big actor, you can load up some dynamic code module on chain, then call it to multiple times, like do some complicated process where you can't just do it all up front. There's some processes you can just say, here's the entire thing. Sometimes like you need to ask something and then you need to like figure out, okay, what next piece of data do I want to send across? With IPLD, this might actually not be necessary, because with IPLD, I can usually just send the entire data tree across because it's already a sharded data set, so it's probably fine. But okay. I didn't want to dig into this too much. I just wanted to like float this idea as a thing.
Yeah, like a simplification of that idea would be, instead of it being a coroutine, right? Like removing layers, just loadable module, library module. I can send you a loadable library module.
The same thing, basically. It's
Not
still
really. It being a coroutine like creates, like at least from my perspective, creates a whole can of other not problems, but concerns and complexity for users. Because now you introduced a element of asynchronicity / concurrency.
Oh, sorry. Here I was thinking about it. It's a synchronous coroutine. So like you call in, it returns. Like it doesn't run on the side. Everything's still synchronous, at least for now. But okay, I just wanted to float this idea and see people's feelings. It doesn't seem to be people to be too interested right now, so we'll move on. The final thing I want to talk about quickly, because I know I'm well over time, is process architecture. It's actually related to what we were just talking about, but this is related to IPC. So we've been talking about how do we build a version of the FVM that is less Filecoin specific? And this gets into questions of, okay, like are actors really that general purpose? Or do we want something even more general purpose than actors? Other questions around like, okay, our message model, like we have a very specific format for our messages, specific format for our blocks, the way we execute messages, all this kind of stuff. What if we could somehow like lift this up and run most of that sort of message execution logic and block validation logic and maybe even some of the consensus decision logic inside WASM? And what this might require is, again, something like these coroutines or these long-running processes. That's one of the reasons I brought them up. The other thing this might require is actually parallelism, because there's certain processes we want to make parallel, and we might want to introduce some form of deterministic on-chain parallelism. And you can achieve this by, again, having a coroutine. In this case, you would asynchronously call and then synchronously join. And as long as you asynchronously call and synchronously join and can't use the process in between, you can guarantee that it's entirely deterministic, because you can't query the state of the actor. You just have to say and wait, and it always returns. So I guess my question here is like, is this something people are interested in? Do people have any use case of this I'm not thinking of? Is there any difficulty here that I might not be thinking of? Or we can move on to the next topic. Okay.
So I thought about this stuff a lot back in my EVM days. It's mainly a performance optimization, as far as I can tell. And even if you think about how, say, Erlang actors work, right? The actor is shut down in between until it gets the message, and then it's woken up, executes, and then ends and has to call itself again to be like, hey, please re-on-queue me to wait for new messages, right? Sorry.
Well, actually, I want to point out, this case is it's not just performance. So one of the problems here is like, we literally want to like move a lot of the actor state tree management into the system, which means like to do that, we'd actually have to be able to like, how to put this, the root process that is like managing the system and executing messages would be running inside WASM. That root process would then have to start up some basically like, I guess, a representation of the state as another process, and then hand off or lend a reference to that process to like the actor it's calling, so that the actor it's calling can then call back into the system and mutate the state. So that's why it does need to be long running in some way.
Right. Why not just use the optimistic concurrency to get the deterministic parallelism, things like that? Like, I like the idea of moving more stuff into WASM, right? It makes it way more portable. Amazing.
Yeah.
But like, why not lean into the blockchaininess since we have transactions? And that's actually been found to be both like easy to reason about and very actually surprisingly performant. In the case where you are restricted to pure computation, which a blockchain is, right? So this actually might be pretty easy to do without having to expose very much to the end user.
So we could, the delayed execution model we have right now makes it very difficult because yes, you could do optimistic concurrency, but you can't take that into account when you're actually thinking how much gas you have in the block because you don't know how much you could actually rely on that before the block has already been produced and published to the network and included in a tip set. So once we have optimistic concurrency, it might be possible to basically do a scheduling step where you figure out, okay, how much gas is really taken? Can I pack any more messages and stuff like that? But it's a bit tricky right now. But I agree. But the other part here is I do want to expose to users because we have some cases where it would be really nice to be able to just I have some structured case where I really want to just spin a bunch of parallel workers. For example, upgrades. I actually want to move upgrades on chain and then have a parallel process on chain that just runs the upgrade inside the actors so that you won't have to do this. Right now we do this in every single client and it's everyone has to implement it the same way and it's not great. Anyone I think had a thing.
Yeah, I'm sort of interested in parallelism as mostly for its performance benefits, like the ability to use multiple cores while validating a block. It's not high on my list, but it's interesting. It's possibly worth the complexity. I'm not particularly sold on any of the pitches about moving more stuff into WASM. I don't think that's, okay. My current opinion is that's not an advantage to Filecoin. There might be other things motivating it, but they're not making Filecoin mainnet better. And so, none of the first bullet point particularly appeals to me.
I can give you two things I do consider to be clear advantages there. One is it makes it easier to potentially build a light client in the browser. And this is something that we have been lacking. But it might not be necessary on the other hand. The real clear advantage is really just upgrades, where if we can move enough into WASM, where we can put all the upgrade logic in WASM, then this will make at least the upgrades less scary, because now we get all the guarantees we have in the FVM around determinism. If we move everything into WASM, does that make sense? Right now, it's always this worry, oh, something goes wrong with the upgrade, something might not be deterministic because it's written in the host language and it's implemented multiple times. If you can't put this in WASM, then it's basically an actors issue, where when you change the actors, you build a migration in WASM.
Yeah, sort of. So you're talking about upgrades that are upgrades to how the VM works, not upgrades to the actors.
I think upgrades to the actor state here.
We want actor upgrades. I get that. So logic that's not implemented in the actors is the migration, the state migration associated with that, which is unfortunately. Yeah. But that is technical debt that we don't use that. We could just do that.
You're right.
Anyway,
we don't actually need the full process architecture.
We can just fix that one.
Yeah.
And then other things that are part of the VM and not part of the actors, currently written in native code, so they get written twice. Pros and cons there. There's a big argument that writing it twice helps us make sure we get it right, because we write it twice and we make sure they agree on the outcome.
Yeah, you're right. Yeah. Okay. Anyone else have any comments before we move on to the next section a bit late?
I have one capability that I think I keep thinking about it, and I would love to someone tell me that it's stupid. So in short, for example, iteration over all miners, right? We don't have good interface for that. So if you want to iterate over all miner IDs, and I don't mean on chain, chain execution, I mean I have a node and I want to iterate over all miners. The way it's done today is Lotus implements a special version-specific code that inspects the state tree and iterates over miners. And the idea I've been thinking about for a while is a query only, pure methods on actors that perform those queries. with the intent that they are not even callable on the chain because their executions are too expensive.
Yeah, the reference implementation of the NFT library does that. It's a pattern that we know how to do. We just, but you're quite right. All of the built-in actors are missing an implementation of that pattern. But that's a thing we can do.
All right.
Yeah. Well, actually,
Go ahead.
we were just bitten the upgrade because one of the methods was removed that we were using in Lotus to validate some stuff. But yeah, having that as an explicit pattern would make this really nice. I think it's also be really helpful for builders as well,
especially.
because like right now, like they want some state from the chain. Like, well, how do I get the state? Well, does it expose by a Lotus API? Nope. We know how to dig into the state. They don't.
Another pattern where I think it would be very, very useful, although there are some caveats there, is as we move towards a more proof-oriented architectures, where you, for example, have to provide a proof for some operation to submit something to chain. A lot of orchestration around that proof could be done in that piece of code that's shipped with actors, right? So then you can use the same code to you use actors code to produce the proof and then submit it on chain.
Oh, that'd be really cool. Yeah, that actually gets into other things I didn't include here. With I would personally love to make the proofs more user space. I know this depends on better proofs, I think, because right now we have to ship around these massive proof parameters, and that's hard to make more user space level. But is there any way of doing this without doing that?
With Graph 16, no.
Okay.
Our proof parameters are too enormous, right?
Yeah. But are there any proof systems we could switch to that would not require those massive proof parameters?
Yes, especially that the size of our proof parameters, verification parameters, very much depends on number of public inputs. And we weren't caring about it that much when initially designing.
That's always the problem. It's always it would be nice, but it's not critical. The biggest wart for the FVM, though, means we have to expose very specific Filecoin APIs, and as we try to expand supporting IPC and other systems, it's they have these special privileged APIs just for dealing with Filecoin proofs, which are kind of annoying. We can make that system more generic, where we might want to eventually have a system where it's effectively a special host call RPC from Filecoin, or sorry, from the FVM, where specific chains would be able to make effectively RPC calls to the host, and then abstract it that way. But that's another thing. Okay, I want to stop this because unfortunately the session we had to shorten it down, and maybe I shouldn't have shortened it down. But I think we have a lot of feedback. And we can take that back to our road mapping